now the other main concept you said is like subgame perfection or backward induction. So again, so subgame perfection, the definition is a Nash equilibrium is subgame perfect if in every subgame people's actions correspond to a Nash equilibrium in that subgame. Okay. So there's two ways of thinking about that. One is just to check, to literally use the definition. So kind of like what we did in here. Where was this? Oh, okay. If okay, so in this case we have let's say take a look at this one for example. This is one does not, and then one does serenade. Oh, sorry, no, sorry, this is not, right?
Yeah.
That's what that is. So, 100 minus 10. 100 minus. Okay. All right. So if what I do to check if a subgame perfect is I write it down here. So one does not. Okay. So one doesn't ask and one doesn't serenade. Then two refuses. Okay. All right. So that's
just that one.
That's this one here. Okay. So we'll use the definition. The definition of subgame perfect Nash equilibrium is play in every subgame corresponds to a Nash equilibrium of that subgame. Okay, so I have to check each subgame. So one of them subgames is this.
Okay.
Is person one, it's as if this doesn't exist, is person one playing a Nash equilibrium in this subgame?
Is he? No.
Okay, so let me do this. What is one getting in the subgame?
He's getting negative 50.
Right, very good. If you were to change, what would he get?
Negative 100.
Right. So is he doing the best thing?
Yes.
Yeah. So actually, it is a Nash.
Oh.
So,
okay.
Now let's check out this subgame. This is where two refuses or not.
And this is including all of this, right?
Right. Exactly.
Okay.
So we're ignoring this, but just including all this stuff. Okay. Can two gain by deviating? What is two getting right now? Two is getting minus 5.
Minus 5.
And if two deviated, what would he get?
Negative 10 or negative 20.
Okay, so two's moving here. Two can't change this, right?
Oh.
So right now two is going up here and getting minus 5. If two were to deviate, two would go down here and get to minus 10.
Okay.
So can two gain by deviating?
No.
Right. So is it a Nash equilibrium?
But he couldn't control one for right here either.
Huh?
Person 2 can't control.
That's right. Oh, so you're okay. Right.
So how can it just automatically exclude that one?
Okay. Right. In the first thing, in this subgame, we only have to consider person 1 because person 2 is just not in the subgame.
Okay.
Okay. So you're right. The question might be, well, how do I know that one's going to do this, right? Okay. We don't, but what we're doing is we wrote down what people are doing, assuming that's true, and then checking whether it's a Nash equilibrium in every subgame.
Okay.
Because your question is a reasonable question. Anyway, so in other words, we're assuming that one was going to play not down here, and then we're just checking whether anybody can gain by deviating.
Okay. And no.
Okay, so yeah, 2 can't gain by deviating, right? She's getting minus 5. If she were to deviate, she gets minus 10.
Okay.
Oh, let's check person 1. Can person 1 gain by deviating? What's person 1?
They could get 100.
Well,
oh, that's player 2?
Yeah, exactly. Person 1 would love to go down here, right? But person 1 is only controlling it up here, right?
Oh, not right there. Yeah. Okay.
So right now he's getting minus 50. He'd like to get, if he deviates, he get minus 100.
So no.
Yeah. So, yeah, he can't get this. He can only deviate this, so he can't gain by deviating. Okay. So the Nash equilibrium in this again, yes?
Yes, negative 50, right?
Yeah.
Negative 55. Negative 5.
Yeah, so this is okay. So now the whole game, can anybody gain by deviating? What is one getting in this game?
He's getting negative 50.
Oh, sorry, in the whole game now.
Oh. Ooh, that's confusing.
It is a little confusing. We start from here, remember?
Oh, okay. I'm still confused.
No, okay. Yeah, remember, one either asks or not.
Okay.
If one asks, then two gets to refuse or go. Then given that, if two refuses, one gets to either serenade or not.
Okay.
Okay, so in this large game,
if he deviates, he gets a better payoff.
Okay, what payoff is he getting?
0.
Right, he's getting this 0 right here.
Which is higher than the negative 50 or 100.
exactly. So can he gain by deviating?
Yes.
Okay, hold on. He could gain if he gets us 100, right?
Mhm.
But given what 2 is doing, given that 2 is refusing, 1 does not gain, right? If 1 plays ask, then what does 1 get at the end?
If one play ask, then wait. What's the question?
Okay. Remember, we assuming 2 plays up this way. That's why we shaded it. And
Okay.
1's playing this way. If 1 right now is getting 0, if 1 were to deviate, what would 1 get in the end? 1 goes up here, and in the end we end up where?
-50.
Right. So can 1 gain by deviating?
Yes.
Well, he's getting 0. If he deviates, he gets
-50.
So is it
Oh,
worth?
no,
Exactly.
Because now we're considering the whole game.
Yeah, exactly right.
Okay.
In this larger game. Okay. All right. So yes, 1 cannot gain by deviating. So it's a Nash equilibrium in this subgame too. The whole thing.
-50, -5.
Okay, hold on. So what is the subgame perfect Nash equilibrium? This is not subgame perfect Nash equilibrium. What is it? It's the entire coloring of all these arrows. So in other words, 1 plays not. So if I were to write it, this would be like not.
Not.
If refused, don't serenade. That's person 1's, and then 2's is refuse. So in other words, it's not like I can point to. It's a little bit different from the matrix where I can say this is the Nash equilibrium.
Yes.
So what it is um, it's a coloring of all the arrows from every point.
Okay.
And like what I said in class today, it would not be sufficient to say. So for example, in this case, what ends up happening is 1 doesn't ask, so we end up here.
That's what I was gonna say. So how can we even put that if it's not? It just ends there.
Right.
Because if kidnapper says no, then you don't even need to go that far.
Exactly right. But the reason we have to think about it is because, again, the reason 1 doesn't ask is because he thinks 2 will refuse.
Oh, so you have to keep that in mind.
Yeah, exactly. That's the whole.
So he chooses not
Right.
if he thinks 2 is gonna refuse.
Right.
Which means.
Right.
Which means he's not. Wait, what was this point?
This is not serenade.
Not serenade.
Right. And 2 refuses if 1's threat. 1 does. Well, if 1 wimps out in the serenade, 2 will refuse.
Okay.
So that's kind of the idea. Is the.
Oh, that's why we include this in our.
Right.
Okay,
exactly.
got it.
Makes sense. So.
Yes.
So this is subgame perfect Nash equilibrium, and the entire writing down of all this stuff is. That's what that.
So it's the highlighted part.
Right. Exactly.
In actuality, like we
Right.
could just go by that.
Right.
Okay.
Okay. So this is. We just checked that this is subgame perfect. Okay. How about, for example,
and then we will have to try. Okay, we have to try all 3 of these, correct?
Right.
Okay.
This is where, let's see, 1 does ask or not. Okay, 2 does either refuse, go. 1 does either serenade, not.
Okay.
0. Okay, so let's see. Okay, so this is what 1 is doing ask.
Mhm. And then
serenade.
Oh yeah, and then 2
is doing go. Okay, in some sense, 1's threat to serenade worked, right? Because 2's going. Okay. So what we observe in this case is 1 asks, then 2 goes, and we end up here. Okay, but let's check if this is subgame perfect Nash equilibrium. To do so, we have to check every subgame. So let's first check this one.
Okay.
Again, as if this doesn't exist. Is 1 playing a Nash equilibrium in this subgame?
Yes. No.
Wait.
Because neither one. No.
Why?
He's playing that, and that's not a subgame.
Exactly. He's getting the -100, and that's you could do better by doing the -50.
Yes.
It's exactly this kind of non-credible thing. He's saying, you wouldn't serenade because it gives him a battle utility as well.
Yeah.
So this is not a Nash equilibrium subgame. So this entire coloring thing, it's a Nash equilibrium, but not
subgame. Okay.
So this is not a subgame Nash equilibrium.
Oh, that's it? That stops there?
Yeah, that's all you have to do.
Oh.
So to show something's not a subgame perfect Nash equilibrium.
You just show for the first step.
Well, okay, it's possible that the first step would have worked out, but the second one wouldn't. In other words, remember the definition. The Nash equilibrium subgame perfect is if in every subgame people's play corresponds to a Nash equilibrium of the subgame. So all I have to do is find one subgame where people are not playing a Nash equilibrium.
Because the definition says all of it.
Right, exactly right.
Oh, okay. Got it. And then this one we kept going because we found it in the first game.
Right.
And in the second game, it was still playing this one, right? And then the third game it was.
Right.
Got it.
So, in this case, every single subgame checked out.
Okay, got it.
Backward
Okay.
inverse. Okay, so that's one way to think about subgame perfection is just to apply the definition.
Okay.
And then there's the easy way, which is the backward induction thing that you said. Then one either serenades. 50 minus 5. Okay, the backward induction is simply easy. You go to the end, and then just figure out what people are going to do. So here, one can either serenade or not. What's one's best choice? One's choosing a minus 100, minus 50.
Negative 50.
Okay, now going down here, two's either choosing to refuse or to go. If two refuses in the end, what does she get?
Negative 5.
Right, she gets this. If she goes down and goes, in the end she gets what?
Negative 2.
Right, so which is the bigger number?
Refuse, so negative 5.
Okay, and finally from 1, does 1 do not or ask? If he does asks, then in the end he gets what?
Negative 5.
Negative,
oh, negative 50.
Right?
And if he doesn't, then he gets 0.
Right.
So 0.
Okay, so this is the fast way of finding the subgame perfect equilibrium. You just start from the end and go way up.
Oh.
That's it.
That was so much easier. Okay.
Yeah, it's much easier.
Much easier.
So in a large game, that's why you almost always find just the subgame perfect equilibrium, because it's very kind of tedious to do all this stuff.
So it's just best to go backward induction.
Right.
Use backward induction.
Yeah.
Wow. Do you mind if we do a homework problem? That'll be my
Sure,
last.
that's fine.
Okay. Can we do number 2? I was like stuck on number 2. Yeah. The 4 orange